Hello, everybody. With great pleasure to discuss with you a class of natural products regarding NMR. Why we take this lesson? Actually, it is quite common to find this class of natural products, and in case you find it as a mixture of fatty acids, whatsoever saturated, unsaturated, or N-glycerides, you don't need to spend the time, effort, and the money for isolation, purification, and structural elucidation. For example, if you got it in a fraction or extract, then simply you could do cellulation and GCMS analysis. But how to recognize it in NMR? Let us see. So this is saturated long chain fatty acid, since it doesn't contain double bond, and this is unsaturated long chain fatty acid, which contain one double bond. So if we look to the proton NMR spectrum, then we expect the chemical shift to be in the aliphatic region, which means between 0 till 6.2. So let us start from the shielded one. So the methyl group, which is not affected by any atoms or any factor, and we call it terminal methyl group. Then it comes to the CH2, which is long chain, and it's not affected by any electron withdrawing group. Then it is normal to find it at 1.2. Then here it comes as a carbonyl group, which means that electron withdrawing group by inductive effect. And then you would expect this alpha methylene proton to be around 2.2. So this is the most deshielded proton as expected. And the next of this, because inductive effect is distance effect, so the beta methylene group, you will find it next here at around 1.5. If you take a new group like unsaturated long chain fatty acid, it means that you will see the same spectra exactly, which means that first is terminal methyl group, not affected, like at around 0.9, long chain methylene group at 1.2, then CH2 neighbored to alpha methylene proton. Then you will find the two extra peaks. The first is a double bond, which is at 5.2, and the next, which is allylic methylene proton, which you will find it at 2. So 2 peaks, you will find it extra than long chain fatty acid, the double bond and the proton next to the double bond. What about if we look to this spectrum? Then you will find here 2 double bond, and in between the 2 double bond, we call it bis allylic proton. This means that you will find the same peaks exactly, but with extra of this methylene proton, and you will find it at around 2.7. So you see, every factor affected the chemical shift as we discussed earlier in the proton and carbon 13. If we look to the carbon 13, then you will find the terminal methyl group. Then it comes to the methylene protons as usual, between 25 and 35, where the double bond, you will see it between 127 to 130. If you take another example, you will see the same spectra exactly, but here you will find the extra big around 4.2. It means that you have glyceride bond. So this CH2, which attached to the oxygen and then carbonyl, it will be more affected due to direct attached of the oxygen atom. So let us see, this is the terminal methyl group, right? Then the next will be CH2, now we know, and then the next is CH2 attached to the alpha methylene proton, and the CH2 attached to the double bond, then the CH2 attached to the carbonyl group, then the CH2 in between the 2 double bonds. Now, you know it quite well, right? Then you will find the next is CH2, which is a glyceride. So the characteristic of triglyceride fatty acid, you will see it clearly at 4.2. And why it is highly deshielded of this methylene proton? Yes, now you know, because it is directly attached to the oxygen, then to carbonyl group. And this is a typical position. And finally, you will find the CH, because CH is less in proton, right? Then you will find it here. And then you will find typical double bond at 5.2. Now you can see the carbon 13. It is the same like before. You will find this carbonyl group here. So if you assign the carbon 13 between 0 until about 80, this is a methylene proton. Then it comes to the double bond and the aromatic region. Here we don't have aromatics, we have only double bond, which you will see around 130. And from 168 is typical of carbonyl group. And this is where you will find the carbonyl group. So this is the assignment of carbon 13, CH3, CH2 in different position. Then CH2, which attached to the glyceride. So the glyceride proton is about 65, and the extra proton, extra carbon, which is less in proton, so is expected to be more deshielded than CH2. So the factors affecting chemical shift of proton are the same factors affecting chemical shift of the carbon 13, and the double bond at 130, and then finally we will see the carbonyl group around 173. So this is typical carbon 13 spectra of triglyceride fatty acid esters. The next is a proton NMR of another group of long chain unsaturated fatty acids, but in this case it is attached also with phosphorus. So like we call it phospholipids, and this you will find it in common, especially in marine. Now you know how to do the assignment. However, we will do a quick revision with you. So the first you will find the end-methyl group or terminal methyl group, which doesn't affect by anything. Then it comes the CH2, which is not affected also by any factor. And then started to be affected. It means that you will see the CH2, which is neighbored to alpha carbonyl. And this is why we like the NMR, because every factor affects in the chemical shift. Then you will find the next, which is CH2 next to allylic proton, and then CH2 next, and finally you will find CH2 attached to the carbonyl group. So this is revision again of what we have explained before, and what is new here, you will see the N-methyl group, which is typical at 3.2. Another, you will find the CH2, which is in between, which is attached to the nitrogen. So the methyl group attached to the nitrogen is at 3.3, and CH2 attached to the nitrogen is more deshielded. We explained before, CH3 first, then more deshielded is CH2, then more deshielded is CH, right? Then the next you will see the CH2, which attached to nearby carbonyl group, and then alpha methylene proton, and then CH attached to the double bond, right? CH double bond, CH, and finally another CH2 attached to the double bond. I think it is easy to identify now the long chain fatty acid esters in different forms, and this is, I will end with these references in case you would like to see more examples. Thank you very much for your kind attention.